of the topic from mechanics. So elasticity is very important property of a material. So to understand in detail about elasticity, we are going to study some of the properties of this phenomena. Before going to start, if you are new to my channel, please subscribe my channel, like and share my videos. So let us start. So how elasticity forms? If the distance between, first we need to understand what is a rigid body. If the distance between any 2 points in a body remains invariable, the body is said to be a rigid body. In practice, it is not possible to have a perfectly rigid body. All bodies get deformed under the action of force. When we apply force, there will be some changes in its size or shape of the body because of the application of force. So there is a tendency of body to recover its original size and shape on removal of that applied force. So the body can come to the original size and shape if we remove the external force. So such property we call it as elasticity. So how we can define elasticity? In the science of physics, elasticity is the ability of a deformable body to resist a distorting effect and to return to its original size and shape when that influence or force is removed. Means elasticity is the state of a material which returns to its original size and shape because when we remove that force. So for example, steel, aluminium, rubber, wood, crystals, these are some of the examples for elasticity. So there are two types of elasticity: perfectly elastic body and perfectly inelastic body. So how we can define perfectly elastic body? If a body completely regains its exact original shape or size after the removal of external forces, it is called perfectly elastic body. As we know, example of rubber or cords. Then perfectly inelastic body, if the body doesn't regain its original size and shape, then such kind of materials are called perfectly inelastic, or we called plastic body. So examples are clay and wax. So then if we want to discuss this elasticity, we should discuss about stress. So when we apply force to any body, it can deform from its original state, and once we remove that force, it can come back to the original state. So these external or internal forces are opposite in direction. So typically it is the measure of pressure, which in classical mechanics we call it as stress. So if a force F is applied uniformly over a surface of area, then we can define stress as the force per unit area. So then formula for stress goes like this: force by area. Then we can write the dimensional formula. Once we know the dimensional formula for force and area, then the SI unit for stress is Newton meter square, and the SI unit of elasticity we can call it as Pascal, or Newton meter square we can also write. The Pascal has the dimension of meter, length and time. So m to the power 1, L to the power minus 1, L T to the power minus 2. This is the dimensional formula for stress. Then there are three types of stresses: longitudinal stress, volume or bulk stress, tangential stress or shear stress. So if there is a change in length, we call it as longitudinal stress. Volume, there is a change in volume or shape, then we call it as bulk stress. Tangential stress If there is a change in shape, then we call it as a tangential or shear stress. So longitudinal stress, it is normal to the surface. The force that is applied is normal to the surface. We can call it as normal stress also. There are two types again in case of longitudinal stress: tensile and compressive stress. Tensile stress, as we can see in this figure, when we apply force, there is an increase in length of the object. Such kind of stress is called tensile stress. Compressive stress, as the name indicates, when we apply force to the object, its length is going to decrease. So the decrease in length is called compressive stress. So bulk or volume stress, when we apply the force from all sides to the object, then its volume is going to increase or decrease. Then such kind of stress is called volumetric stress. Then what is shear stress or tangential stress? The restoring force per unit area parallel to the surface is called tangential or shearing stress. Here the force is parallel to the surface, so there is a change in shape of the object by changing its angle. So this is called shear stress. Once we understand stress, we can understand strain. So the unit change produced in the dimension of a body under a system of force in equilibrium is called strain. So the strain is being a ratio, it has no unit, that is change in dimension to the original dimension. So here it is the ratio of two similar quantities. That's why it is unitless quantity. So again, like stress, we have three types of strain: longitudinal or linear strain. So here also we have the formula, that is change in length will give the longitudinal stress or linear strain. So change in length to the original length, we call it as a linear strain, or so we call it as elongation strain or tensile strain. Volume strain, as the name indicates, change in volume to the original volume. Ratio of these two is called volume strain. So shearing strain, as we can see here, there will be a change in angle of the object when we apply force to that, so which is parallel to the surface. If there is a change in shape of the body, there is also a change in its angle. So we can define it as a displacement of upper face to the displacement distance between two faces. So tan phi, that is small l by capital L. The angular deformation produced by an external force is called shear strain. So what is elastic limit? So there is some limit to any object. It can extend or it can deform to certain extent. So when we apply stress, the stress at which the linear relationship between the stress and strain hold good is called elastic limit of the material. What is Hooke's law then? Once we know the elastic limit, we can understand Hooke's law. So the fundamental law of elasticity, it is called, that was given by Robert Hooke in year 1679. So according to this law, provided the strain is small, the stress is directly proportional to the strain. So one of the good example is here stretching of a spring when we apply weight or load to that, which is directly proportional to the applied load. So in other words, the ratio of stress to strain is constant quantity for a given material, which we call it as a modulus of elasticity. So we can understand it by formula, that is stress is directly proportional to strain according to Hooke's law. So if we remove proportionality, we will have this capital E, which is stress by strain. So this capital E is called modulus of elasticity. So unit and dimensions of modulus of elasticity are the same as that of stress, because strain is unitless, stress has the unit Newton meter per square. So what is the relation between stress and strain? We can understand it by diagram. So if we plot stress versus strain, so how the body can have the elastic property, so by this curve we can understand. We have we have mentioned with alphabets O A B C D F E and G. So here we have mentioned each reason with a particular phenomena. So from O to A, that is when we apply stress to any material, strain it can have the elastic property. So stress is directly proportional to strain. So this obeys OA obeys the Hooke's law. So after that it is A is called the elastic limit, point A. After that, when we apply force, it can extend further. Okay, here we have mentioned elastic limit, and this is called elastic range. Then after that, beyond this point B, if once we unload at B, it doesn't come back to its original condition along path AO. So the dotted path BC, which we can understand it as a permanent set. So the object is said to have acquired permanent set, and OC is called the residual strain. Here OC, which is called the residual strain. Then beyond the point B, the length of the wire starts increasing without any increase in stress. So when we apply load to the material, it is going to extend without any stress. So after that, what happens? The wire start increases without any increase in stress. Thus wire begins to flow after point B, and it continues up to D. The point B at which the wire begins to flow is called yield point. So at point B we can have the yield point. So beyond the point F, the graph indicates that the length of wire increases even if the wire is unloaded. So at the end, wire will break. How much you load apply, what happens, the wire will break at the end. So that is called the plastic reason. It cannot regain its original shape. That is called plastic or inelastic reason. So this is how we can understand stress and strain with the help of diagram. So then what is modulus of elasticity? So if we take the ratio of stress to strain, that is called modulus of elasticity according to Hooke's law. So there are three types of modulus of elasticity: Young's modulus, bulk modulus, and modulus of rigidity or shear modulus. So there are totally three types of stress, three types of strain, and three types of modulus of elasticity. So first one, Young's modulus. Here the force applied per unit area of cross section is called longitudinal or linear stress, and the ratio of longitudinal stress to linear strain, which we call within elastic limit, that is Young's modulus. We denote Young's modulus by capital Y. So if we consider a length of wire having cross sectional A, then longitudinal stress is given by F by A and linear strain is given by small l by capital L. So then Young's modulus, we can define it by longitudinal stress to the linear strain, F by A divided by L by capital L. So Y is equal to Young's modulus equal to F into L divided by A into L. So the Young's modulus has the unit of stress like Newton meter square and or in CGS dyne per centimeter square. So we can define Young's modulus as the force applied to a wire of unit length and unit cross sectional area to produce the increase in length by unity. So then another modulus, that is bulk modulus, that is related to volume. So if we take the ratio of normal stress to the volume strain, then we call that as a bulk modulus, which is denoted by capital K. If we consider a cube of volume V, surface area A, then the force F acts uniformly over the surface of a cube, which produces decrease in volume. Then we can take the normal stress F by A, volume V by capital V. Then modulus of bulk modulus, we can write F into V divided by A into V. So then stress, that is pressure, F by A. We can write this bulk modulus as negative PV divided by V. So if the volume increases, on increasing the stress, the bulk modulus is given by K is equal to positive PV by V. So decrease in volume and increase in volume, we can write the bulk modulus. So the unit for bulk modulus is also same, Pascal or Newton meter square. So the reciprocal of K, we call it as a compressibility. So the another one, shear modulus. It is defined as the ratio of tangential stress to shear strain in this formula, that is denoted by eta. So if we consider a rectangular block having the edges A, B, C, D, once the force applied parallelly, its angle is going to change, that is deformation is given by change in angle. So let us take the AD as capital L length and change in deformation A to A prime, that is small l. Then we can write tangential stress F by A, and the change in angle is given by AD A prime theta. Shear strain, angle of shear theta. So the ratio of these two will give the shear modulus F divided by A into theta. So for solids, angle of shear is very small, that's why we can take a theta which is approximated to tan theta, A by A prime divided by A into AD, that is L divided by capital L. So the final equation for shear modulus is given by F into L divided by A into L. So this is about shear modulus or rigidity modulus. So another important phenomena, that is Poisson's ratio. When we stretch a wire, it becomes longer but thinner. The increase in its length is always accompanied with a decrease in its cross section. The strain produced along the direction of the applied force is called primary or linear or tangential strain, that is denoted by alpha, and strain produced at right angle to the applied force is called secondary or lateral strain. So then how we define this Poisson's ratio, that is lateral strain to the linear strain, it's equal to beta by alpha. If the body under tension suffers no lateral strain, then this ratio is going to be 0. That is beta is equal to 0, this ratio is going to be 0. This is all about elasticity. I hope this is very helpful for you to understand the phenomena of elasticity.